The idea of multiple regression. Multiple regression is used when you want to determine the effects of two or more independent variables on a single quantitative dependent variable called y. The idea of multiple regression is conceptually the same as simple regression, except that there is more than one x variable. We call them x1, x2, x3, etc. We assume that y is a linear function of all of the x's. That is, y can be estimated as an intercept plus a coefficient times x1 plus a coefficient times x2 plus a coefficient times x3, etc. The coefficient or slope of each x variable is the increase in y as that x increases by 1 unit, assuming that all of the other variables are held constant. The basic idea of multiple regression is to estimate the relationship between y and all of the x's in the population based on the relationship in the sample. The estimates are found by identifying the linear equation that best fits the observed sample data, that is, that minimizes the error or difference between what the equation predicts and what was observed in the sample. The equation that minimizes errors is the multiple regression equation. The estimates of the coefficients of x1, x2, x3, etc. are called b1, b2, b3, etc. The first step in determining if and how the independent variables affect y is to test the overall model. The null hypothesis states that none of the x's affects y, while the alternative states that at least one of the x's affects y. The test statistic is an F statistic representing the amount of variation in y that is explained by the x's divided by the amount of unexplained variation. If the F is large, statistically speaking, a large amount of variance is explained, so at least one of the x's is probably affecting y, and we reject the null. If we do not reject the null in this step, the model is considered ineffective and no further analysis is done. But if the null is rejected, we next want to determine which of the x's affect y. To see if there is evidence of a relationship in the population between y and each individual x, we do a hypothesis test, each one like the test in simple regression. For example, the null of one test would be that the population coefficient of x1, which we call beta 1, is equal to 0. If this occurs, no relationship exists between x1 and y, because when x1 is multiplied by this 0 coefficient, it disappears from the equation describing y. To test this hypothesis, we look at b1, the sample coefficient for x1, and see how far away b1 is from 0. If b1 is too far away from 0, we have evidence that beta 1 is not equal to 0, and that there is a relationship between x1 and y. However, if b1 is fairly close to 0 statistically speaking, we conclude that the population slope beta 1 could be equal to 0, and so there is no evidence of a relationship between y and x1. This test is then repeated for each of the independent variables x2, x3, x4, etc.
Created using Powtoon.